Section 7.3, the last section of chapter 7. Now, we already discussed interval for proportion of this, interval for proportion of populations, and also two formula, two interval for proportion of the mean. And mean has two formula. One is when the standard deviation of populations are given or is known, and the second is when the standard deviation is not given or is not known. The only difference, the formula are the same. The only difference is here we are using z-table versus t-table in this case. The last one is when we like to calculate the interval for standard deviations. You understand that sigma to power of 2 is the variance, and when you take the square root of this, just the sigma by itself is the standard deviations. So if I put a radical on top of each of these, then what you have here is standard deviations. But this one is the variance. So what you have under the radical is the variance, and when you take a square root of that number, that would be a standard deviation. So for standard deviation, all we need is value of n, number of samples, and a standard deviation of the samples, and then these two values, x2L and x2R. Now, for these particular sections, and this we have to use the table. We cannot use the calculator unless there is a special software that we have to load into the computer. But so we need to find these two values, x2L and x2R, right and left. There are requirements. Sample has to be random samples, the simple random sample, and population must have normally distributed value. Now, so what is important in this section is how to find these two values, x2R and x2L. x2 doesn't mean it's x to power of 2. This is just a symbol we use. x2R means it's this point, and x2L is that point. And you understand the horizontal axis always start from 0. Now, how do we calculate? The way to calculate is, if you want to find x2R, you need to know what area is from this point to the right. Basically, you need to find this area, which in this case is 0.25. So first of all, the graph is not normal distribution look. You remember the normal distribution, they had a symmetric one, but this is not a symmetric. However, the tail area are still equal. So if you have 95% confidence, like what you have in these problems, then if subtract from 100% area under the curve and take this 0.05 divided by 2, area of each tail is 0.025. Now, what we need is from the point to the right, what's the area? For instance, x2R. What is the area from this point to the right? This area of the yellow is 0.025, and n is 21. So you go to this table for degree of the freedom and for area to the right of the critical value. See, this is area to the right of that point. So what is the area to the right of x2R is 35.479. So this is this area. And you know the number always increases from 0. So this number, x2L, always has to be less than that because the numbers start from 0 and keep increasing. So what is area to the right of this point is 0.025. And n was 22. So df is 21. So you go, df is 21, area to the right of this 0.025. So 21 and 0.025. Now, What about the X2L, the left? How do I calculate this? What is the area from this point to the right? This area. That would be 0.95 plus 0.025. So what is the area to the right of 10.28? Means this area, all this area is to the right of this, right? So it's 0.95 plus 0.025, or you could just say the whole thing is 1. And if I subtract this little one from 1, or 1 minus 0.025, that gives me this area. So if you take 0.95 and 0.025 and add together, that would make it 0.95 plus 0.025, it give you 0.975. So area to the right of this point is 0.975. So you find that from here. See, area to the right, 0.975 from here. DF is 21. That gives you the value of 10.283. So basically what we need to do in this section is very important to understand how to use the table and how to find these two values. You see the shape is not symmetric anymore. So for standard deviation, section is not symmetric. It looks like this. But remember, the tail area still are the same. They both have the same area. So if d of f is 10, the graph looks like this. These are examples. And d of 20, the graph looks like that. And this is the formula that we have on the first page. But this is the variance. Remember, for standard deviation would be sigma, not to the power of 2. So this one basically is the variance. If we ask you to find the variance, but most of the time we will ask you to find the standard deviation. So here, this is again variance, and this is a standard deviation. So you always have to put a radical at the top, take a square root of the whole fraction underneath of it. Like on this problem, n is given, s is given. We have to find x2L and x2R. When you calculate those two, then we plug it into this formula. That gives you the variance. This is the variance. Now, if I take a square root of these two numbers, that would be a standard deviation. So a standard deviation is equal to a square root of variance. So what you could do, instead of going through 2 steps like that from the beginning, since we are looking for standard deviations, you could use this formula. You don't have to do this and then take the radical in the half. You could just go ahead and use this formula to find the standard deviation directly. And this is the table. They call it chi-square distributions, this kind of table. And as I said, if you want to use TI-84, you have to download and install Michael Lloyd program. If you want to do it, but it's easy to use the table. You don't really have to use the program. Like for these problems, problem number 11, clinical trial was concluded to test. So for that one, the confidence level was 0.98. Again, when we subtract that from 1, it's 0.02 divided by 1. Area of each tail is 0.01. Although they don't look like they're equal, but they are. These two areas of the tails are equal. So if this is 0.01, the other one is also 0.01. Then we go to the table with df of n minus 1, which is 15. Then you find x2r and x2l. When you find it, you plug it into these equations because s and n is already given to you. So we don't actually use the mean in these problems. And this is a table related to that. How do you find it? So the first one, what is area to the right? What is this area to the right of this point? What is this area? This area is 0.01. See, 0.01 is area to the right. 15 is 30.578. That is this number. And the other one, what is the area from here to the right? It's 0.98 plus 0.01. So it's 0.99. 0.99 area to the right with the same degree of freedom, it give you 5.229. So we are using the formula to do the homework. The first one is just a multiple choice questions. On this one, all the values are given. S is given 90%. So for 90% confidence, you have to go and find the value of X2L and X2R. When you plug in the equation, you find the interval for standard deviations. Now, this is a problem that has a bunch of numbers. And remember, for when you have a bunch of numbers, you get to input that because you need to find the S. You need to find the standard deviation of the sample. So for that, on L1, you go and put all those numbers in L1. See? You put all these numbers in L1. And then if you just want to calculate the standard deviation of the sample, because that's what we need in the formula, right? We need to have a standard deviation of samples, which the instruction is on this page. So what we need to do is first we need to edit, put all the numbers in L1, which are these numbers. Then when you have all the numbers here, go to stat, calculations, then scroll down to one, various stats. The very first one, we already have it, is a default. And we know all the information is already in L1, so we don't have to do any changes here. You just go straight to calculations. The value of S, the standard deviation of the sample, is 3.728. And that's the only number, and N is 12. That's the only number that we really see, N is 12. That's the only number that we use here. We need to have S, we need to have N, we don't need a mean. And these two, we calculate that based on the confidence interval. We said the confidence interval is 95%. So this area is 0.95. And when you subtract from 1 and divide by 2, area of each tail is 0.025. So for this one, you use 0.025. For the other one, is 0.95 plus 0.025. And that gives you the standard deviation. This one, we need to input all these numbers and do the calculation and then the other numbers. I didn't do it because it's time consuming. Okay, and it said explain here that we don't have it in TI-30. We have to use star disk or Minitab to do that. And these sections, there is a table here. This table indicates that if he's 95% confidence or 99% confidence, like in these problems, the confidence is 99%. So if it's 99%, which is here, and S is within 1%, S is within 1%, which is these sections, then the value of a standard deviation, the sample sizes, this is the way they calculate the sample size based on this information. So the sample size was 33,280. So this is how to find the sample size for the standard deviation. It has to go according to this table. So it has to be one of these numbers in order to find that sample size. Okay. All right. So that would be end of chapter 7.